Hello everybody. Today we're going to go through LeetCode problem number 88, which is merge sorted array. So this says you are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, or increasing order I like to call it, and two integers m and n, representing the number of elements in nums1 and nums2 respectively. So we're going to merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be sorted inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So if we look at example 1, m is 3, so that means the first three numbers are relevant, and then the rest zeros we're going to ignore. Nums2 is 2, 5, 6, n is 3. The output merges those two lists. Example 2, nums1 is 1, nums2 is nothing, so we're just going to output the 1. And again, m represents the amount of elements in nums1, and n represents the amount of elements in nums2. Example 3, nums1 is 0, nums2 is 1, so returns a 1. M is 0. There are no elements in nums1. The 0 is only there to ensure the merge result can fit in nums1. And as a follow-up exercise, can you come up with an algorithm that runs in big O, m plus n time? We sure can, LeetCode. We sure can. All right, let's try to do that. So this is the method that LeetCode gives us. Int array nums1, the amount of relevant numbers inside nums1, an int array of nums2, and n denotes the number of elements inside nums2. So the first thing we need to do is get rid of those annoying zeros inside nums1. We don't need to concern ourselves with those. So I'm going to instantiate or create a new variable nums1 copy, which is going to be a new int of size m, which is the number of elements inside nums1 that we care about. And we're just going to loop through those until we get assign nums1 copy equal nums1, until we get just the three using the example 1 from the exercises, this will just be 3, and we'll get rid of the extra zeros. So the next thing we need to do is assign two pointers. So we need to traverse through nums1 and nums2 and compare the numbers in each. Actually, we're going to traverse nums1 copy and nums2. And pointer 1 will correspond to nums1 copy, and pointer 2 will correspond to nums1 2. And we'll find the smaller of the two numbers, and then we'll stuff that back into nums, because LeetCode wants the result to be in nums1. So we're just going to loop through those two numbers. So I is less than m plus n. So we're taking the values that are relevant in nums1 and the number of values in nums2. Okay, so here is our check. So basically we need to say if pointer 2 is greater than or equal to n, which means if we've exhausted all the numbers in nums2, so we're out of numbers in nums2, or we still have values in nums1 copy that are relevant, and nums1 copy, the value at pointer 1 is less than nums2, the value at nums2. Then we're just going to assign nums1 copy the value at pointer 1. Let's just say it's 0. Nums1 copy 0 into nums1. And the plus plus here means we're going to increment pointer 1 afterwards. So we don't want to compare this number anymore. We put it in num, so we want to forget about it. If the plus plus was prior to the pointer 1, then we would increment pointer 1 before we used it, but that's not the case here. Else, So this means that we still have values in pointer or in nums2. It means we still have numbers to go through. Pointer 1 can still have values as well, but this is basically saying that the value in nums2 is less than the value in nums1 copy, or equal. If they're both equal, it's going to go into the else statement. And so then we just put nums2, the value at pointer 2, into nums1. And that is pretty much it in the method. So let's go through the debugger here and see if we can make more sense of this. Okay. So why is it not? No, it helps to hit the debugger button. Okay. So as you can see, nums1 is 1, 2, 3, 0, 0, 0, and only the first three numbers are relevant. Nums2 is 2, 5, 6, three numbers there. So we have a new nums1 copy that just has the three indices we need, and we're just going to put those three values in nums1 copy. So now nums1 copy is 1, 2, 3, which are the three numbers we need out of nums1. And we're going to instantiate or assign these pointers to 0. So now we're going to loop through this 6 times. M plus n, 3 plus 3 is 6. Okay, first time through. So now we're comparing in nums1 copy the 1 to the 2 in nums2. So pointer 2 is greater than or equal to n, false, meaning we still have numbers inside nums2, and we still have values to go through inside nums1 copy. And nums1 copy 0 is less than nums2 copy, which is true. So we're going to stick the value in nums1 copy, which is actually the 1. We stuck the 1 into nums1, but you can't tell because nums1 already had 1 in there, so it looks like we didn't do anything. But anyway, so now we're comparing, we incremented pointer 1, so now we're comparing 2 to nums2, 2. And it's going to go down here because these two values are equal. So it's not less than in this case. And so we're going to put a 2 into nums2, I'm sorry, into nums1 and increment pointer 2. All right, so now we incremented both nums1 copy. So now we're comparing the 2 to the 5. So this should, yep, there we go. So it should go into this first case and add. So there, now we see nums1 has changed because this used to be 3, but we added the 2 from, what is it? Yeah, here, nums2. Our nums1 copy. Okay, so now we're going through here, and we're comparing the 3 to the 5. And so now we add the 3 into nums1. So now we've actually gone through all the numbers in nums1 copy. So this is just going to add the remaining numbers, 5 and 6, to nums1. And you see there, it's added 1, 2, 2, 3, 5, 6, and we return that. And you can see up here that it is 1, 2, 2, 3, 5, 6, which if we go back to LeetCode, 1, 2, 2, 3, 5, 6 is the result we should see. All right, while we're in LeetCode, let's just run this and then submit. Wow, we are amazing. We're always the fastest submission. And use less than 56.93 percent memory. Okay, so finally I'm going to go through the time and space complexity. So time complexity in this case is m plus n. As we increase the amount of, or the numbers, the amount of elements in nums1 or nums2, the execution time goes up. And then space complexity is O of n. So same thing. If we increase the values in m or n, then we're going to take up more space. And that is it. So thank you for watching. Good luck in those interviews, and we'll see you next time.